So in this next section, we're going to be discussing oceanic circulation. So what that is it's the patterns that water moves around the Earth. So surface currents, what they are movements of water located near the surface of the ocean. They're caused mainly by prevailing wind patterns that we discussed in the previous section. These prevailing wind patterns create gyres, which are these circular ocean currents that you see right here. Okay, so in the northern hemisphere, you'll notice that they flow in a clockwise direction, while in the southern hemisphere, they mainly rotate in a counterclockwise direction. This difference is largely accounted for by the Coriolis effect, which is that effect of the movement of fluids due to the rotation of the Earth, as well as by just the position of different land masses around the planet, which cause changes in direction in these surface currents. Now, deep ocean currents, they're largely affected by temperature and density, and differences in density are usually caused by varying amounts of salinity, so differing levels of salt. Now, this cooler, saltier current, it's actually deeper down and it sinks and flows under the less salty, warmer currents. So these currents right here are flowing underneath the warmer, less salty currents. And the movement of these shallow and deep currents, they're shown in this diagram. The ocean conveyor belt, it can be affected by, it can affect regional climates. Like, as you can see right here, the Gulf Stream, what it's doing is it's pushing warm water from the equator up north into Europe, and it actually has a warming effect on Europe's climate. So if the Gulf Stream didn't have that moving warm water, Europe's climate would probably be substantially different. Now, these currents, however, are susceptible to change and they may fluctuate with varying conditions. Now, the next thing that we're going to talk about is just oceanic and atmospheric interactions. Largely, we're talking about the process of El Nino and La Nina. And what these two things are is they're a periodic, large-scale warming of surface waters of the tropical Eastern Pacific Ocean that temporarily alter both the ocean and atmospheric circulation patterns. So this happens roughly every 3 to 7 years. And what this El Nino effect can do is it can have a devastating effect on fisheries off of the coast of southern America, mainly because of decreased upwelling and cooler bottom waters. And the way that upwelling can cause this devastation of fishing populations is what it does is upwelling is the process of when cool water comes to the surface. And as this cool water comes to the surface, it provides nutrients for microorganisms and microscopic algae. And this algae in turn then supports the rest of the food web. So without it, the food web is likely to collapse. So during El Nino, the process of upwelling is slowed significantly. So there's obviously less nutrients available, and so there's like a greatly reduced fishing availability during these times. Okay, so that was your video for section 5. Thanks for tuning in. I'll put up the one for the next and last part of chapter 5 in a little bit. Thanks.